Right, hello. Time to continue on with the rest of the Sveltekit tutorial. I hope everyone's having a good week. Let's just set ourselves up a little bit here. That's ready. That's all there. Good. Right, so same as the last few streams, we're continuing on with the official Sveltekit tutorial. We did the basic Sveltekit bit in the last stream on Saturday, I think it was. And we're now going to start on the advanced Sveltekit. So we've got a few sets left. Maybe we might be able to get through all of this, but it depends on how confusing the topics are or how in depth we go into some of the examples. But we'll see. We'll just work through and see. So just as a little recap, Sveltekit is an app framework that sits around or on top of the Svelte component framework, which in turn is a JavaScript framework for web development. So Sveltekit helps you by solving tricky problems like this stuff. So routing, server-side rendering, data fetching, service workers, TypeScript, integration, pre-rendering, so on. There's quite a lot that it does. But basically, it's just a way to build Svelte apps easier. Is the main idea. So let's jump into our first lesson on hooks. So Sveltekit provides several hooks, which are ways to intercept and override the framework's default behavior. The most elementary hook is handle, which lives in our source files as a hooks.server.js file. It receives an event object along with a resolve function and returns a response. Resolve is where the magic happens. Sveltekit matches the incoming request and URL to a root of your app. It imports the relevant code, loads the data needed by the root, and generates the response. Okay. The default handle looks like this. So it exports a handle function, which is an async function, which receives an object with event resolve parameters. It receives an event object along with a resolve function and returns a response. Return await resolve event. So it's like a callback for your event. Okay. For pages, you can modify the generated HTML with transform page chunk. So here in our server, in our hooks file, we want to resolve event, we're doing this. Transform, we can type say, transform page chunk. All right, let's just type it out and then we'll review what it does. Replace, and we're replacing our body tag. Oh, okay, I can kind of see what this is going to be doing. We can override bits. Body with style, color, style equals color hot pink. We'll get there eventually. Hot pink. Right. Resolve event. So we're passing this resolve function, our event, and this function as well that will take an HTML element and replace it. So like string wise, we're replacing anywhere that it has an opening body tag with an additional style on the opening body tag of this style hot pink is what it looks like it's doing. And then that closes our replace. This closes our event. And this closes our function handle. Right, okay. And then we can also create entirely new routes. Wait, if we go to our page file, let's just refresh this. Why is that not working? Well, what else we're saying here is before we're doing our return. So if events.url.pathname is equal to /ping, then we are return new response pong. This needs a closing bracket here. Right. Okay. So a handle receives an event along with a resolve function and returns a response. So why are we not getting this hot pink color style? Because I've probably spelled this wrong. Yep. Right, okay. So this is every event. Lives in hooks.server.js. So what I'm trying to figure out, why is this being called all the time? Or what is calling this? So then this is still the same response structure that we saw before. Okay, that's nothing new there. So even on ping, do we have a body style? Wait, we need specifically the body in here. This body doesn't have the style on it. But if we go back to the home page of this and look up the table within this iframe, sorry, in this document, here, this body does have it applied to. So what's making the difference there? Sveltekit matches the incoming request URL to a root of your app, imports the relevant code, loads the data needed by the root, and generates a response. Ah, wait. So if we're at the path name ping, then we're getting this. This is our return. So we won't get to this return. So I think this is running on every page. I wonder if we can have a look at an example. Let's get rid of these. So let's play with some other bits there. So if we add in hooks.server.js file in our root, is it in our root or in our src? Oh, it's just in the source folder. So in here we're adding a new file, which is hooks.server.js. And we want to do something like this. But let's say if we're looking at like just part 1 for this. It's complaining because of TypeScript, so that should be fine. So then if we look at our function here and go back to our part 1. Oh wait, we've got to run it first. pm run dev. Let the local server spin up. Okay, and then refresh here. So part 1, we just get Pong now. Okay. We just go to the home page, we get this hot pink, right? And any other page. So why would we want to do this though? For any page that we visit, we can run some server code. I guess we're going to see a more useful example in a minute. So let's comment this out for a moment, because we don't want it breaking the rest of our example files. Right. Yeah, I'm going to assume we're going to find more useful examples in a second. Okay. The event object passed into handle is the same object, an instance of a request event that is passed into the API route in server files, or form actions in page.server files, and load functions in page.server and layout server files. So this event object is just like passed around most of our files by the looks of it. It contains a number of useful properties and methods, some of which we've already encountered. So it has a cookies property. So it's an instance of, oh wait, I don't mean to do that. Request event. So these are all types that have been defined in Sveltekit. Okay, I don't think we need to care too much about that. Get client address is data request. True if the browser is requesting data for a page during client-side navigation. False if a page route is being requested directly. Locals, a place to put arbitrary data. Okay. Params, which is the route parameter. Request, which is the request object. Route, which is an object with an ID property representing the route that was matched. Set headers for setting HTTP headers. And the URL, which is the current request. Okay. A useful pattern is to add some data to the event.locals in handle so that it can be read in subsequent load functions. Okay, so in our hooks.server.js, we can add in our events.locals.answer. Answer. Which in this case we're setting to 42. And then in our page file, in our page.server.js file, we can pass the event object See, I think that's what's confusing for me. It's calling this object event. It's like we could probably destructure this into a locals.answer locals, and then part of our string here we can do locals.answer, right? Is it going to let us do that? Yeah. It's the same object as passed into load functions in page.server.js file. So I wonder, actually, can I just pass the full event here? Let's see what that is. Oh. So this data.message is now what if I pass it the event like that? So if I did .params instead, right? Is this going to be an object? What? Why can't I just pass this in? Can I just return event params? Right, so that works. Confused why I can't just do the object. Okay. let's just continue on and have a little look. Right, so we can, in our hooks file, we can set parameters on the locals data object, and then we can retrieve them through the server for specific pages for that page data. Right, okay. Right, up next, handle fetch. The event object has a fetch method that behaves like the standard fetch API, but with superpowers. It can be used to make credentialized requests on the server, as it inherits the cookie and authorization header from the incoming request. It can make relative requests on the server. Ordinarily, fetch requires a URL with an origin when used in a server context. Okay. Internal requests, e.g. for server routes. So internal requests go directly to the handler function when running on the server without the overhead of an HTTP call. Its behavior can be modified with the handle fetch hook, which by default looks like this. Okay, so in our hooks file, we have a handle fetch function. That we pass in this lot and we await a fetch. For example, we could respond to requests for the server file in A and with responses from B. Right, okay. So on our hooks, we could say const URL equals new URL request dot URL, and then we're saying if URL dot path name is equal to /a, return await fetch B. Let's refresh this. Why is it not like that? So on our home page here, we're not doing anything. Oh wait, we are. We are saying okay, so we are saying we need to load the message data when we come to this page, which is the data that is returned on this message, which is the response here to text when we call await, when we call fetch A, which should go to here and give us a response from A. But our hook is jumping in the way of this and saying if the path name of the request, which this fetch is doing a URL, it's doing a request to this server file. So we can jump in the middle and redirect it. Otherwise we just call it. So we do so we just comment this one out. naturally it does the hello from A. But by adding this in, we're intercepting and overwriting. Okay. Not entirely certain on the use of that just yet, but it's probably a good reason. Its behavior can be modified with the handle fetch hook. Yeah, okay. Later when we cover universal load functions, we see that event fetch can also be called from the browser. In that scenario, handle fetch is useful if you have requests to public URLs like api.yourapp.com from the browser that should be redirected to an internal URL, bypassing whatever proxies and load balancers sit between the API server and the public internet when running on a server. I think this is getting too deep into the weeds for me. I'm sure if I do a project around this kind of functionality, then it would make more sense. But in these examples, I think I just need to know more about how this is how this normally works for this to make any sense for me. So we're just going to continue on for the moment. Handle error. The handle error hook lets you intercept unexpected errors and trigger some behavior, like pinging a Slack channel or sending data to an error logging service. Okay. As you recall from an earlier exercise, an error is unexpected if it wasn't created with the error helper from Sveltekit. This usually means something in your app needs fixing. The default behavior is to log the error. So in our hooks, we want to log our error, okay, and we can have our terminal just here. I can't shrink that. Okay. So if we navigate to our bad place link, we'll see this in action. The error page is shown, and we should see a message from our bad place server JS file. So if we go here, we get our error here, which is this is the bad place. We get a 500 message because in here we're throwing the error, whereas in the good place there's no server. Notice we're not showing the error message to the user. That's because error message can include sensitive information at its best. That at best will confuse your users, and at worst it will benefit evildoers. Instead, the error object available to your application, presented as page error in your error Svelte pages or Sveltekit error in your error HTML fallback, is just this, message internal error. Right, okay. So if we do here our Sveltekit.error, do we see that message here? No? Right, let's take that off then. In some situations, you may want to customize this object. To do so, you can return an object from handle error. So in our hooks server file, we do this, and we can return message. Message. Everything is fine. Code. Jeremy. Okay. So in our file here, everything is fine. Oh, we need a fill on there. So yeah, this is the bad place. Everything is fine is output here because that is the message that we're overriding the default message with our error hook. So if we got rid of this line, it's undefined. Shouldn't this return to internal? Yeah, that's internal error. Oh, but because we are returning an object here, even if we don't return a message on it, the message is undefined now. Because we're overwriting the default object anyway. Okay, I think. So we can now reference properties other than message in a custom error page. So we can create an error Svelte page. And in this, we can do a script file. So I can type. We're importing the page store from our app.stores, and out here we just want to do an H1 with our page status. So we're just getting the status now. And then if we want to do... Oh, didn't quite mean like that, but that'll do. We turn these into P tags. We'll get that in a second. Right, and then instead of status, we want our error.message. Oh, really can't type today. And then this is error.code, right? So this is how we could return some like meaningful code for our users to tell us. Based on what error we receive, okay? I could see that being useful. Right, our next page options. There's definitely stuff in that hooks that went over my head though. I think I need to do some practical examples to figure out what that's actually doing. Right, page options. In the chapter on loading data, we saw how you can export load functions from page, page.server, layout, and layout.server files. We can also export various page options from these modules. Whether or not it's server-side rendered, whether to load the Sveltekit client, whether to pre-render the pages at build time instead of per request, Whether to strip, add, or ignore trailing slashes in URLs. In the following exercises, we'll learn about each of these in turn. Page options can apply to individual pages if exported from page or page.server files. Okay. Or groups of pages if exported from layouts or layout.server files. Okay, that makes sense. To define an option for the whole app, export it from the root layout. Yep. Child layouts and pages override values set in parent layouts. So for example, you can enable pre-rendering in your entire app and then disable it for pages that don't need to be dynamically rendered. Okay, so whatever we set in our main layout file, so if we had a layout file here, we can overwrite it by we can overwrite the values lower down the chain for those specific pages. That makes sense. You can mix and match these options in different areas of your app. You could pre-render your marketing pages, dynamically server render your data-driven pages, and treat your admin pages as client-rendered single-page applications. This makes Sveltekit very versatile. Okay, I can see that. So SSR, server-side rendering. Server-side rendering is the process of generating HTML on the server and is what Sveltekit does by default. It's important for performance and resilience and is very beneficial for search engine optimization. While some search engines can index content that is rendered in the browser with JavaScript, it happens less frequently and reliably. That said, some components can't be rendered on the server, perhaps because they'd expect to be able to access browser globals like window immediately. If you can, you should change those components so that they can render on the server, but if you can't, then you can disable server-side rendering for the page, right? So if we did server-side rendering false to our root layout server, it turns our entire app into a single page app because everything has to be rendered on the client end, right? So at the moment, we'll get an error because what's happening is it's trying to render this page on the server where the window object doesn't exist. Because that's on the client end, right? But if we go into, if we just set here, we need to make a server file. Sorry, even. Let's do that. We do a server.js file. And here we're going to say export const SSR equals false. And now we're saying don't render this page in the server, just serve it directly to the client. And then the JavaScript here is only run on the client end. Right, okay. Client-side rendering is what makes a page interactive, such as incrementing the counter when you click the button in this app. So at the moment, it should click and enable Sveltekit to update the page upon navigation without a full page reload. As with server-side rendering, you can disable client-side rendering altogether. So again, same thing. You could have just left. They could have left us a page.server file. I think creating a new file here isn't that useful. So export const client-side rendering false. And now we're saying this means that there's no JavaScript is served to the client. It also means that your components are no longer interactive. This can be a useful way to check whether or not your application is usable for people who, for whatever reason, cannot use JavaScript. So this is allowing you to test your server, test your client-side code for, as in emulating users that have JavaScript disabled. So what we're saying here right, so if this line isn't here, when we first load the page, we get this server-side rendered version of the page, and then it's updated with the client-side browser version of the page when it notices this is updated, which then allows this interactivity to occur, because this is then able to run. But if we have this on, we never overwrite the server rendered version, which doesn't have the JavaScript enabled. Okay, I think I get that. Pre-render. Pre-rendering means HTML page for... pre-rendering means generating HTML page for the page once at build time, rather than dynamically for each request. The advantage is that serving static data is extremely cheap and performant, allowing you to easily serve large numbers of users without worrying about cache control headers, which are easy to get wrong. The trade-off is that the build process takes longer, and pre-rendered content can only be updated by building and deploying a new version of the application. To pre-render a page, set pre-render to true. So we need to do a first page.server.js file here. And we're gonna export const pre-render was true. Here in the tutorial, it won't have any observable effects since this application is running in dev mode. Not all pages can be pre-rendered. The basic rule for this: for content to be pre-renderable, any two users sitting it directly must get the same content from the server, and the page must not contain form actions. Pages with dynamic route parameters can be pre-rendered as long as they are specific in the pre-render.entries. As long as they are specified in the entries property of pre-render. Configuration. Either they're put in that pre-render configuration, or they can be reached by following links from pages that are in that link. Okay. Setting to pre-render to true inside your root layout server file effectively turns Sveltekit into a static site generator. So I imagine for a lot of websites, that's good to do. Unless you're loading or fetching data for your pages. If you only have it as pre-render false for the pages that need to go and fetch data or submit form actions and stuff like that, then you save yourself a ton of hosting costs, I think. This isn't going to do anything here, right? Yeah, it doesn't do anything in this version. Okay. We'll come back to that because I think that could be useful in terms of like cost efficiency, saving money for hosting, but there's a load of other benefits for that, like better performance on the websites, even looking at the environmental impact. Could be cheaper and easier, and so less energy usage for serving smaller static sites rather than the whole build. Okay, so the training slash, two URLs like foo and foo slash might look the same, but they're actually different. A relative URL like dot bar slash dot slash bar even, will result to bar in the first case and foo bar in the second. And search engines will treat them as separate entries, harming your SEO. In short, being loosey-goosey about trailing slashes is a bad idea. By default, Sveltekit strips trailing slashes, meaning that a request for foo with a trailing slash will be ignored and redirected to foo. If you instead want to ensure that a slash is always present, you can specify the trailing slash option accordingly. To accommodate both cases, this is not recommended, use ignore, but this will hurt it, and the default value is never. Whether or not trailing slashes are applied affects pre-rendering. A URL like always will be saved to a disk as always/index, whereas a URL like never will be saved as a never.html without the index, right? So, never is the standard default behavior. Let's assume that we do a page.server.js file here. What we want to do is export. I'm trying to do this without looking down to the left there. Const. And what's it called? Trailing slash. What's this? Always. So we want to set it to always. Like that. And then when we go to always, that doesn't seem right. Export const trailing slash equals always. Let's just enable that for the moment. Okay, I think that should work, but it doesn't look like it has properly. Page.server.js here. And in this, we want to do ignore, which is not recommended. So we go to ignore or ignore. Yeah, so this is the behavior I'd expect for ignore, where the slash is left in if we go to, well, I'm assuming actually if we go back to our layout. Yeah, so the link that we're going to based on these links is exactly what it says in here. So never is the default behavior. But it's not doing it, it's not taking out the slash. Let's get it to solve for us. So confused as to what this is actually meant to be showing us in this tutorial. It doesn't seem to be doing what I think it's saying it should do. I'm expecting, like, when we click on this never link, that it automatically redirects to this never link. So basically it's saying if there is a trailing slash, strip it out before the navigation occurs, because we know that it's going to the same place as this. But it doesn't seem to be doing that. So yeah, I'd expect this to be automatically going to this link. But it always oh, that works then. Wait, does it matter which route I'm coming from? See, look, that's added the trailing slash there. If I go back to never now, yeah. Oh, so it's got some issue about routing itself to the same page. Okay, so it is doing what I expected, but it fails if you re-render the page. So what we'd expect is always, regardless of which link we click on from another page, we'll be navigating to /always/. So like if we click this one that doesn't have the slash in it, we get it rendered in or added in. I suppose it's not really rendering. If we go to ignore, it will return whichever one we click on. So without the slash or with the slash. Like if we jump off with the slash, without the slash. So it ignores any trailing slashes and just takes you directly to that link. And if we click on never, it will always take out any trailing slashes that are in the link in the URL. But it doesn't like it when we're already in that route. It seems to fail. It's only navigating onto that page that it does this check. Is there a way to explain why that is? I guess because we're not actually navigating. Okay. There's a bit of confusion on that bit, but we'll keep on going. Link options. So in this exercise, the slow A and slow B routes have artificial delays in their low functions, right? So on slow A, we're waiting a second. Slow B, we're waiting a second. Okay. Meaning it takes quite a long time to navigate to them. You can't always make your data load more quickly. Sometimes it's out of your control. But Sveltekit can speed up navigations by anticipating them. I think we covered this in a previous example when I was demoing something. Basically, with links, with Svelte, when the user hovers over a link, in the background, as long as you're on the default parameters and don't override this, it will go and fetch the data required for that link before the user clicks on it. So you get the extra like half-second lead time over the user clicking on the link to preload what that link is going to need to render. So when an A element has the Sveltekit preload data attribute, which this one does, Sveltekit will begin the navigation as soon as the user hovers over the link on desktop or taps it on mobile. Try adding it to the first link. So on our page here, on our layout. So at the moment, we have our home, we have our slow that's going to take a second, and we're going to have our slow B that's also going to take a second, plus a little bit extra. But if we go to home, and we add in this data, Sveltekit, preload data, then B is still going to have the delay, 1 second delay, but because it preloads it before I click on it, we're getting the extra. We've already started this countdown, so this 1 second countdown starts before we even click on it. So there'll be a second and a bit delay to navigate across this page. But this one, if we wait a second, we can immediately load it, because based on how long the user is hovering, it starts this request as soon as the user hovers over it. I wonder if, so if we're on here, home, it obviously doesn't unload that request. So we can load the full request now by just hovering. But if we hover over B, nothing's going to happen. But if we then suddenly click on A, because it's already loaded it, it doesn't restart that load. I wonder if that can get you into some issues as well. Where if a user just sits on a page for too long. might load the links away from that page because the user's hovered over it, but then the data might be out of date by the time the user actually clicks on that. Potentially. Right. Okay. Starting navigation on hover or tap rather than waiting for a click event to be registered might not sound like it makes that much of a difference, but in practice it typically saves 200 milliseconds or more, and that's enough to be the difference between sluggish and snappy. I mean, most page transitions you probably have the data loaded in this kind of time frame anyway. You can put the attribute on individual links or on any element that contains links. The default project template includes this attribute on the body element. So we look at our body element here. I think they've probably taken it off for the moment on this, which is down here somewhere. Yeah. So taking it off for this example, but if we go to our example folder here, we have it here set by default in the Sveltekit template files. So customize the behavior further by specifying one of these following attributes. So you can turn it off if you don't want it to do it. That you might want to turn off on specific links if it's got like a massive data load in that link and you don't want to clog up someone's mobile network, for example, or maybe even on mobile views. But you're not going to get it much on mobile views anyway, because the tap functionality doesn't really happen, does it? You don't hover over links, and if you tap it, you're probably going to navigate to it, right? So that's not really going to make a difference. Using preload data may sometimes result in false positives, i.e. loading a data in anticipation of a navigation that doesn't then happen, which might be undesirable. As an alternative, preload data code allows you to load the JavaScript needed by a given route without eagerly loading its data. Okay, this attribute has the following values. Eager preloads everything on the page following a navigation. Viewport preloads everything as it appears in the viewport. Hover, which happens as above, and tap and off. So you can initiate preloading programmatically with the preload code and preload data. Okay. So if we want to cause this without the hover, without the user even having to interact with the page, we can do this. So let's say that's on our page file, right? I think. So here, if we do our script, I think this is what this is saying. We can import preload, let's see, data from app navigation, and when the page is loaded, we want to just like preload data / slow a. Actually, let's do B. So now what we should see is, regardless of what happens on the home page, we should automatically get the preload data, shouldn't we? Why is that not? I'm confused there. So what are we actually saying here? I mean, it's clearly doing something different now because we're getting slow B times of less than the second delay that we're expecting, right? Let's make this 5 seconds just so that it's a bit easier to see, and let's make this 10 seconds. That's a bit too much actually. Let's do 5 and 3. So on our home page, let's reload this. Reload again. Why is it getting errors? Server responded with status 500. We can't see. Right, so God, that 3 seconds feels really slow. So we hover over for this for a bit from home. That works quickly. Oh wait, do we need this? Wait, we might need this in a layout file. Okay, let's see if that helps. So from home, that's doing the full 5 seconds, isn't it? Okay, I'm not entirely sure. So navigating from B doesn't call our load function because we're not reloading the page. Navigating to A from any page, obviously except itself, starts the timer when we start hovering, so we can get fast loads. Is the same thing for B? Or is this still 5 seconds? That's still 5 seconds. But when we had it in here, I'm sure it was happening quicker than 5 seconds. Let's get rid of it out of this. Yeah. So somehow this isn't preloading the data, it's just giving it the hover effect again. Because if we just suddenly click on it, you still get the full 5 seconds. Yeah? But if we hover over it, it's giving us the same preload data hover attribute. I thought this was saying we could tell it to do the hover attribute anyway. Which I think this is what it's saying, but maybe it's not implementing it properly here. I think we'll do some testing of that in our test project later on. So reloading the page. Ordinarily, Sveltekit will navigate between pages without refreshing the page. In this exercise, if we navigate between our home and about pages, the timer keeps on ticking. So even though it's the different pages, because in the layout is what's counting, and that's where our anchor tag is below. It knows this section is the bit that it just needs to re-render, and the layout doesn't change, so this doesn't have to be restarted, which is normally quite good. That's what you want. In rare cases, you might want to disable this behavior. You can do so by adding the data Sveltekit reload attribute on an individual link or any element that contains links. Okay, so just directly on the nav here, data Sveltekit reload. So now when we navigate between, it reloads the whole page, so the counter gets restarted and it doesn't share that between. Okay. For more information on available link options and their values, consult the documentation. On to advanced routing. Right, how are we getting on? Done 3. There's 3 more. Let's carry on through advanced routing, and then we might take a first break. So in the first chapter on routing, we learned how to create routes with dynamic parameters, which was the slug terminology that we've got here. So within these square brackets, we have this dynamic parameter called lang. Okay, sometimes it's useful or it's helpful to make a parameter optional. Classic example is when you use the path name to determine the locale. So French or German, so on. You want to have but you also want to have a default. To do that, we use double brackets. Rename this lang directory for the double brackets, so it's now optional. The app now fails to build because our page and optional page files will both match our index. So now what we're saying is we don't need this page file because our default route is still this, just without the lang parameter filled in. It'll be undefined, right? So we delete this page. Now Svelte knows how to route, and yeah, it's undefined because our parameter lang is empty. So it's now trying to do greetings of an undefined. So it's trying to look up in this object undefined. Can I specify undefined? Undefined home. Just give it time to update. Yeah, so I can specify if it's undefined, so we can leave a default there. Or, okay, or here, if it is undefined, we can specify it this way. So now it's, if lang is not populated, so for example, where we go into here and say, let's put JK, this will be undefined because it doesn't match anything in our array. But if we go to FR, for example, we get bonjour. Cool. That's very useful. I like that. Okay, rest parameters. To match an unknown number of path segments, use a spread operator. Oh, okay. Let's so name for its resemblance to rest parameters in JavaScript. To rename our path to a spread operator or rest. I suppose it's the same thing. The route now matches any path. So this So other more specific routes will be tested first, making REST parameters useful as a catch-all route. For example, if you need a custom 404 page for pages inside categories, like this, you could add these files. And that will give you an error page and a server. You throw the 404 function inside the load, so when the error page is loaded, for any catch-all. Okay, that's cool. REST parameters do not need to go at the end. A route like items path edit or items is totally valid. So does this say that it will match any route as long as it's got an edit end? That's quite useful. That's very useful. Right, so now it doesn't matter what we put in here. What we're doing is we're taking the page store, we're taking the parameters path, and we're splitting on slashes. For each word in the slice, return word. Okay, so right, if we click on this anchor tag, we get a link to next. This word.depth. Bit confusing. So depth is based on our current number of slashes, basically. So well, it's the current number of words in this. So if we did like the rest of this story, yeah, so because we've got what 1, 2, 3, 4, 5, 6, 7, 8 layers into our root here, we get right to the end and that resets. Right, okay. So you can, that's quite interesting. So based on like how nested the root is. Okay, cool. Our next param matches. To prevent the router from matching on invalid input, you can specify a matcher. For example, you might want to route like colors value to match hex values for colors, but not named. So hex colors with a hex value, but not named colors like octarine or any other arbitrary input. First, create a new file called params.hex.js. So in our source file, I want to make a new file. Can I just do it? I think I can just do params hex.js. Should work. No, okay. Got to do the folder first. Params. And inside the params folder, we're going to do our hex.js file. And inside our this, we want to do export a match function that takes a value and returns what? Returns this regex check. So we're saying it has to start with the 0 to 9 or A to F. It has to be 6 characters. And that's it. Okay, so test against the value. Yeah, so it has to be 6 characters from 0 to 9, A to F. So it has to be a hex value. Okay, now when... Okay, so color equals hex. So we're giving a check here, and it's telling us to look for params. That's quite cool. So to use the new matcher, yeah, whenever someone navigates that route, Sveltekit will verify that the color is a valid hex value. If not, Sveltekit will try and match the other routes, eventually returning a 404. So there's no invalid route, so that doesn't work. But if we did, I can't remember what's, is it 00A877 I think is our brand green. There we go. I think that's right. It's either that or 788. I think it's 877. Yeah. You can see it at the top right, the text up there. Matches run both on the server and in the browser. Okay. Next, route groups. As we saw in the routing introduction, layouts are a way to share UI and data loading logic between different routes. Sometimes it's useful to use layouts without affecting the route. For example, you might need your app and account routes to be behind authentication while your about page is open to the world. Okay, we can do this with route groups, which is a directory in parentheses. Create an authored group, authorized group basically, by renaming account to auth account. Okay, so we're saying this directory, oh sorry, should be auth account page, then rename app to auth app. Okay. Right, so they both fit within our auth to route now. Now we can control access to these routes by creating a layout server file here. Layout server.js. And we're going to import our redirect functionality from the Svelte Sveltekit library. And we're going to export our load function. Which looks at our cookies, and we want it to look at cookies and URL of that event. This is where I'm getting so confused. So in these server files, where we're destructuring something, is always the event object that we covered previously. So we can only access properties of that event object. So if we look here for the event object, do we have that full object info? Form actions, no. Hooks. Hook server. There was something that we were looking at earlier. Glossary, hydration, no. Matching, no. Errors, accessibility. Yeah, the public types, was it? Maybe we'll get a link through here. Where's this event object again? I'm sure we were looking at it. Is it in types? Down here should be... Oh wait, are these all types on the event object? No. I'm sure we saw it earlier somewhere. Okay. Locals defines event.locals. Okay, well, we'll come back to that. But yeah, I think within our load functions, or within our server files, I think we're always applying to this event object, and this is just destructuring and finding the cookies and the URL parameter on that object. So if not cookies, so if cookies haven't been set yet, oh no, sorry, if the logged in cookie hasn't been set, logged in, then we want to throw a redirect. We want to redirect our user 303, which I think is unauthorized, but we'll check that again, to our login redirect to our url.pathname. Let's see what 303 is. See other. I'm sure there's like a not authorized. Forbidden 403 maybe. Okay, so now if we go from home to about to our account, we get a redirect to... Okay, so this is saying once we've logged in, we can be redirected to the right file. So this is taking us to this login page here with an item saying that once we have this, if there's a parameter already for the redirect, that's where we go to. Otherwise we go back to home. So we just go directly to the login page like this, and we click login, which I think is all we need to do. That will post, which will call this actions function, which will set our logged in true cookie, and we get redirected to home because our redirect to is not there. And now that we're logged in, we can go to the account page and the app page. But if we refresh, wait, how do we clear the cookie? Is it a cookie that's set here? Let's delete that and see. Oh, if we reload the page, it's gonna reload all this, and that takes a little while. Let's see if we open this and we do cookies here and delete this one. That's what we want to do. We can reload this page. Maybe. Nope. Broken something now. Okay, let's reload the whole page. we'll solve this because we don't have to do that again. And when it's loaded, oh, we also added a layout. Okay, so this is that login, and we're just adding a log out button. That's useful. Okay. So when we click log out, we're posting to where? To our logout function here, which deletes the cookie. Right, okay. That's useful. So at the moment, we can't go to either of these, but when we log in, this will take us to the app because we've got it on the direct to, and we get our logout button. That. Cool, okay. I like that. Breaking out of layouts. Ordinarily, a page inherits every layout above it, meaning that ABC page inherits all the 4 layouts. Occasionally, it's useful to break out of the current layout hierarchy. We can do that by adding the @ sign followed by the name of the parent segment to reset to. For example, page at b.svelte would put ABC inside of layout.svelte. What? Well, A would just put, okay, right. And root is just the @ okay. So at the moment we've got all of these extra stuff around this page that's loaded. But if we reset to this, then what's changed? Right, okay, yeah. So the page here in B has the root layout, the A folder layout, sorry, the A root layout, or the A directory layout is probably the best way to say it, the B directory layout, and this would have had the C directory layout as well, but because we're resetting it, we just jump out into the root layout, which is the outer border. Cool. Root layout applies to every app in your page, so you cannot break out of it. So I guess if you wanted to have like a breakout, you'd have to put all of your files in like a standard sites folder with the curly brackets, like we did the grouping before. Advanced loading. Right, we're going to do a quick break here. Just a little bit of screen break. And where's our timer? Yeah. Right, back in a little bit. Right, we're back. Let's get rid of this stuff off the screen. And that little timer. Right. Advanced loading. Universal load functions. In the previous section on loading, we loaded data from the server using our page server file and our layout server file. It's very convenient if you need to do things like getting data directly from a database or reading cookies. Sometimes it doesn't make sense to load data from the server when doing a client-side navigation. For example, when you're loading data from an external API, or you want to use in-memory data. If it's available, you want to delay navigation until an image has been preloaded, which avoids pop-in, or you need to return something from load that can't be serialized, such as a component or a store. In this exercise, we're dealing with the latter case. Server load functions in red, green, and blue return a component constructor which can't be serialized. So we have a look here. Right, so it's this marquee component, and that can't be serialized into JSON, so it's going to fail. So if we open up our terminal here, and we try and navigate to green, for example, we get an error. Data returned from load while rendering green is not serializable. Right? To turn load functions into universal load functions, rename each page server file to page.js. Now the functions will run on the server during server-side rendering, but will also run in the browser when the app hydrates or when the user performs a client-side navigation. Okay, so .server tells it only to do it on the server, but if we just have a page.js file, for example on blue, why are we not getting the marquee? Return color blue, which on our layout, I guess, is our page data color. Yep. Where's our marquee element though? Okay. Oh, we can now use the component returned on these load functions like any other, including in our layout.svelte. So on our page, we have a page.data.component, which we're putting here in our nav bar. That's why it wasn't rendering. We haven't called it anywhere. So if page, from our store, we have a page.data.components element. Then we can close out RF here. And within this, we can render with our Svelte components directive component, if we get there. This page.data.component, and we can close it out here. This equals. So this is our component that we're rendering in. In this, we're going to do the same, and the same in this one. We can do this. So now, when we go to green. Oh, it's just a green marquee and a red marquee. Okay. So when we go here, we get hello from green. And that is added to the end of our nav bar as our marquee element. It will scroll across and disappear about here. Yep. And reappear. Read the documentation to learn more about the distinction between server load functions and universal load functions and when to use which. That seems quite useful. So that's that example, but I think these three examples are probably more useful implementations. This is just to demonstrate what's happening more. Next, using both load functions. Occasionally you might need a server load function and a universal load function together. For example, you might need to return data from the server, but also return a value that can't be serialized as server data. In this example, we want to return a different component from load, depending on whether we got it from our page.server. Oh, depending on whether the data is cool or not. This data came from the server, it's true, cool. Which is our boring component. Okay. We can access server data in our page file via the data property. So if our module, so if our data here, data.cool, then we're going to output our data.message. Note that the data isn't merged. We must explicitly return message from the universal load function. So this data came from the server. So we're passing the value of cool and the message from our server file into our universal load function, and that updates this data. So I guess if we did like a wait, how did we do that before? With link options, preloading. Let's have a quick look at this. So here on our server, this is what we want to do. Something like this. Universal, no, both ones. We're on the next one. So if we do an await new promise. Wait, let's do the solve. But this time with a timeout. Wait new promise. Let's make this like 5 seconds. So the message by default doesn't exist. If data is cool, then use this one, otherwise use this one. But boring component, let's just say this is like awaiting server message, server load. Let's say that. Get rid of you. And let's load this. Why is it not rendering while it's loading? I want to see this boring component. Or nothing. Let's do this. And then in our boring component, we can undo all of this. Or, okay, let's do it here. Waiting on server. How do we get this boring component to render? Okay, so this returned false. Why is it erroring now? We should get our boring component. Right, okay. But it's still the data came from the server. Occasionally, you might need the server load function and universal load function together. Might need to return data from the server, but also return a value that can't be serialized. Okay, yeah, that's this moot point again there. Okay, so I think for this example, it's just going to be that kind of demonstration. Let's move on though. Using parent data. As we saw in the introduction to layout data, Svelte and layout file components have access to everything returned from their parent load functions. Occasionally it's useful for the load functions themselves to access data from their parents. This can be easily done with await parent. To show how this works, we'll sum two numbers that come from different load functions. First, return some data from our layout server.js file. So we're going to return a value of a equals 1. Oh, didn't mean that. Then get that data in our sum layout file. So we're going to load this parent function. And we're going to say the returned a equals await parent. And then we're going to return b, which is our a plus 1. If a equals 1 and b equals a plus 1, what is a plus b? So in sum, we got a. Okay, so this is going to fail at the moment because we're not setting data.c. So to finally end this page, get parent data from both the load functions. So we're going to say parent here. Const c equals parent. No, const a and b from parent. Return c as a plus b. This is what I'm imagining it should be. Not a number. Something I've done something wrong there. Await. We don't have an await. There we go. So we get the parent data from both load functions. Okay, so take care not to introduce waterfalls when using a wait parent. If you can fetch other data that is not dependent on parent data, do that first. Okay. I assume this is more interesting if you have delays on the data being set as well. So next, invalidation. When a user navigates from one site to another, from one page to another, Sveltekit calls your load functions, but only if it thinks something has changed. In this example, navigating between time zones causes the load function in our time zone page file to be rerun because params.timezone is invalid, but the load function in our routes layout file does not rerun because, as far as Sveltekit is concerned, it wasn't invalidated by the navigation. Right. So what should be changing though? Turn now. Why do we think something's wrong here? Doesn't look wrong at the moment, but we'll have a look. We can fix that by manually invalidating it using the invalidate function, which takes a URL and reruns any load functions that depend on it. Because the load function in layout calls fetch API now, it depends on API now. Oh, I get what's wrong. Right. So because we're navigating, we should update our time. But we're not updating the time. It's the first time we've used this function call. We've used this API call when we first load the page. So we're now 2:27:11 in China. Or, yeah, almost 7:30 here in the UK. But when we navigate time zones, we're seeing, or our current Svelte app is seeing our time zone change because the parameters here are changing, and it's doing a lookup based on what the standard time is based on the location. But it's not recalling this function, which is in our layout file. So, because the load function in layouts was the fetch function API net, this one, it depends on the API. So in our page.svelte file, we want to add an on-mount callback that calls invalidate every second. So if we import on mounts from Svelte, there we go, and import invalidate from our app navigation, so and then we say on mounts, we want to run a function and this, it sets our set interval interval, which we're going to do set interval invalidate the root API / now, and we want to do that every second. Right. That. And then we need to return clear interval with the interval flag. Close that. And close that. Is that right? That's closing there. That's closing on our on mount, and that's closing here. What just opened up? Let's refresh this. We've got some brackets mismatched somewhere. No, we don't. That's fine. So what this is saying is, when this page is loaded, which is our whatever time zone, we want to start this set interval counter that every second runs the invalidate function on this route. So because it's invalidating this every second, and this file is dependent on that route, this response is being invalidated every second. So this function is reloaded every second. So a new time is given back to us every second. That's my understanding of that. Note, you can also pass a function to invalidate in case you want to invalidate based on a pattern and not specific URLs. Okay. Up next, custom dependencies. Calling the fetch function inside a load function registers URL as a dependency. Sometimes it's not appropriate to use fetch, in which case you can specify a dependency manually with the depends URL function. Since any string that begins with an A to Z pattern is a valid URL, we can create custom invalidation keys like data now. This I think is going a bit over my head now. Update our root layout file to return a value directly rather than making a fetch call, and add a depends. Okay. So we want to say this depends on data now. So instead of all of this, we say depends data now. Okay, I think I understand. Date.now. Else I can do this. Now update the invalidate call in our page.svelte file. Right, okay. So now every second our set interval is finding the now property. Is it a property? Depends URL. Oh, it's a key, right. So it's saying invalidate this key every second, which is telling this file to rerun this line of code. to recalculate what this value is. I'm assuming it's picking up directly this. So if we set this to like data test, test, then obviously that should stop working. But this here is not just a straight key, is it? It is, okay. So now is... So if we say like plus 2000, does that do anything? Yeah. Right, we need to add way more to actually see the effect. So there's nothing to do with this API anymore. We're not calling this at all. This is now just running the JavaScript function for date now, returning the value of now to here, to this value. And this is just a key to tell us, invalidate anything that's tied to this key, which is this one. So is this any properties on here would be invalidated if we said like a message here of this. Actually, let's do we do a template string here. The time is now, and then we do now. Like that. That should... we do data.now, data.message here. Doesn't like that. Let's do const counter count equals 0. Can we do that? Time is now 0. Okay. So we should see... No, that's not how that's working. Set and count to 0. Yeah, that's never going to be doing that. But I want to show that this is being updated every second as well. Wait, so this line is being rerun every second? Can I do that? No. Something like this. No, it's not a store. No, okay. Getting a bit confused with this. I can't access the data property here, can I? Okay. I think I know what's happening there, but I'm just struggling to show that it's doing it. But anyway, invalidate all. Finally, there's a nuclear option, invalidate all. This will indiscriminately rerun all load functions for the current page, regardless of what they depend on. Ah, okay. Update our page.svelte from the previous exercise. Go call invalidate all. And obviously we don't need to pass in this key anymore. Okay, the depends call in layout.js is no longer necessary now, because we're not using this key anymore, so we don't need a depends. Asset. Invalidate true and invalidate are not the same. Invalidate all also reruns your functions without any URL dependencies. Invalidate true does not. Okay. Up next, environment variables. Environment variables like API keys and database credentials can be added to a .environment file, and they will be made available to your application. You can use .env.local or .mode files, see Vite documentation for more information. Make sure you add them to your get ignore so they're not tracked by Git and uploaded to your GitHub folder or your repo stuff. Environment variables in process.env are also available via env static private. I think that should be further down because we haven't covered that yet. In this exercise, we want to allow the user to enter the website if they know the correct passphrase using an environment variable. So in here, we have our passphrase, which we're going to change to Open Sesame. Or Open CSAME, right? And then in our page, in our welcome page here. So at the moment, if we do Open Sesame and press enter, wrong passphrase because it's not looking at our environment file. So what we want to do here, on our server, sorry, redirect fail, we want to import our passphrase. Passphrase from env static private private and here so we type in test here and enter, we get this fail where incorrect is true. So incorrect is set to true, we get error, wrong passphrase. But Open Sesame is correct. So then We set our cookies allowed to true. We set our path to home. No, on the home path, sorry, for our cookie. And we redirect the user to the welcome page. And only if we've got the allowed cookie are we allowed to see here. And if we log out and we try and go to the welcome page, we get this 403 forbidden. Okay. And obviously we don't want to do something like this that we were having a look at. Because I think if we go now to our home page, oh, it doesn't even let you do it. Okay, that's even better. I was going to say, like, in our console, we'll be able to get access to this passphrase. But it looks like Svelte has an automatic check that stops you to do it. It's important that sensitive data doesn't accidentally end up being sent to the browser, where it can be easily stolen by hackers and scoundrels. Sveltekit makes it easy to prevent this from happening. Notice what happens if we try to import... Oh, literally what I've just done. An error overlay pops up telling us that private cannot be imported into the client-side code. It can only be imported into server modules. In turn, these modules can only be imported by other server modules. Okay. Static versus dynamic. In static, private. Also, the static here indicates that these values are known at build time and they can be statically replaced. This enables useful optimizations. Okay. In some cases, you might need to refer to environment values that are dynamic, or variables that are dynamic. In other words, not known until we run the app. We'll cover this in the next exercise. If you need to read the values of environment variables when the app runs, as opposed to when it's built, you can use dynamic private instead of static private. Okay. So in our server file here, we're going to change this to our env parameter in dynamic private. So now we're going to get env.passphrase from here. Open sesame, and that lets us in. So we can't actually see the difference here because obviously there's nothing changing it here. But this could be updated based on other variables in the application, I'm guessing, when the app is run. Okay. In static public, some environment variables can be safely exposed to the browser. These are distinguished from private environment variables with a public prefix. So in here, we can say steel blue, and East. Okay. So rather than this being black and white, we want to import them. So say import, public theme background, and public theme foreground. From our static public. So these can be used in our client-facing or client-side Svelte files because we told them that they're public. But if we had if we still had the passphrase here, phrase of open up. And we tried importing passphrase here. It's not going to let us, right? Passphrase. Passphrase. Right? It doesn't let us do that, right? Internal error. So if we look here, is it telling us no? It's undefined. Does it error though? Are we getting an error in the terminal? Hey X3, how's it going? Hope you're good. Been a while. Mainly my fault because I haven't been streaming that much, but hope you're good. Doing a bit of Sveltekit learning, going through the official tutorial and just seeing some of the bits that I've missed when I've done it before, and trying to get a better understanding of what's going on. So I think we're getting this internal error because this is not allowed to be accessed. Oh wait, no, because it's not in the public folder here. So if we try to copy this, let's take it passphrase out of this. Let's take all of these out of here. Ooh. So if we have a look on private, it's going to complain. We can't use private. So we can only use public where we specifically said in our environment variables this public prefix. And now, undefined. No. Passphrase here. Passphrase from static public. Is it because I've separated them out? Let's do that. I don't get what I've done. Oh, because it's now public underscore passphrase. Okay. So this name has to be public though. What we tried to call this like private. I don't think this is going to let us do it, right? Yeah, so this is undefined because it doesn't get pushed into this public directory. So it's failing. So delete or blank. It's just errors entirely, right? Because it can't get access to this. Okay. Interesting. So in our dynamic, as with private environment variables, it's preferable to use static values if possible, but if necessary, we can use dynamic values instead. So when the app is run, in which case we can import our environment from dynamic public. And now we can get access to these from this kind of setup. So if our environment file is based on runtime rather than build time, we can access them public variables like this. Cool. And that's it. Congratulations, you've made it the entire way through this tutorial. You now consider yourself a Svelte and Sveltekit expert. I think a few more exercises and tests first before we jump ahead to that kind of claim. You can start building apps on your own machine with Create Svelte. Svelte and Sveltekit will continue to evolve, and so will this tutorial. Check back periodically for updates. To keep up with development in the Svelte world, join our Discord server at svelte/chat. Follow Svelte Society on Twitter, and happy to welcome people to the community. Nice. I was expecting more from the end page rather than just putting the end. I know that they're probably more focused on doing updates. I know Svelte 4 is coming out pretty soon. So I imagine the tutorial's taking a little bit of a back burner approach here for the moment. But I'm sure when we complete the advanced steps here, we get a bit more of a fanfare, don't we? But yeah, okay, so there's quite a few things that I'd like to look in a bit more detail within these topics. And it might be an idea to look at the examples now. And see if we can explain them in more detail now that we've done the learning portion of it. But yeah, I think mostly got a fairly decent understanding. There's a few bits here that are probably more practical hands-on is necessary to understand it in more detail. But how many examples have we got here? There's quite a few of them, but this will show a bit more showing a bit more detail what goes on. So this being the dynamic attributes styling that's scoped to the component, nested components. So our CSS doesn't affect the p tag in our nested component here, even though they're both paragraph elements. HTML tags we want to steer clear of. Reactive assignments, so this is our buttons, that's fine. Reactive declarations, saying as we increase our count, everything updating with the click. Reactive statements, nice and easy as well. Oh, this is with our counter popping up. Nothing too different. This is all the same as the tutorial actually. So let's keep going down. Those are all the same. DOM events. These are just the solved tutorials, I think. Is there anything new here? Binding this to the canvas. Again, it's cool stuff, but all the same as what we've done. Tick events. That's some useful stuff, that's fine. Transitions, deferred transitions, this looks like a new... That wasn't in the tutorial. Right, what is this showing us? So this is showing us, we have all of these, we have this array of objects for our photos with the path. We're getting crossfade here. Oh, it's doing send and receive events, okay. So in our container here, we have all of our images in this grid. So on click, when we send an on click event, we're waiting for the image to be loaded, and in between we've got our 3 dots. So you see very briefly, so if I click on 12, 12 becomes an ellipsis message while it's waiting for the photo to be loaded. And then once it's loaded, we won't see that again because it doesn't need to. Any picture that we've already clicked on will instantly load. And it's sending out this ID, so a key for the animation or the transition. Okay, we kind of get an idea of that. An ease visualizer. It's quite useful. So you can see your different curves. Cool. Some SVGs. So this is our SVG, the whole box. We've got a circle with a radius 48 units. And then for each of these array, so each element in this array, we're drawing a line from Y1 to Y2. So from 35 units from the center to 45 units away from the center, so up to the edge, and we're rotating by the percentage. So 30 degrees times 5 gives the rotation of this one, right? Wait, no, wouldn't that be way more rotation though? That can't be in degrees then. That would give 150. Is that correct? When we're down here, it's be 30 times 30, 900. Maybe that is right, just by coincidence. So at 10, we're rotating 300 degrees, which is almost a full circle. And at 0 and at 30, we just happen to rotate I'm not sure that's correct, but anyway. So each 1, 2, 3, 4 as offset. Okay, so we're looping through each of these main thick blocks here. And for each of those iterations through, we're also adding an offset line for these little short markers that are only they're drawn from Y42 to 45, so that's why they're a lot shorter than the main thick ones. That's cool. So every second we're changing the value of time. And because of that, our hours, minutes, and seconds gets updated. And because of that, the hands are updated, but the clock background won't be, I think. Nice. So what's this showing us? This is just showing us some more SVG tricks. So for example, if we drop this down to like 11, or okay, boost it way up, or way down. Okay. Well, I think we'll come back to some more examples at another point. I guess this is just fetching fetching articles from Hacker News, all that kind of stuff. But yeah, we've finished the tutorial. Don't know what the plan is next stream. I think maybe we're just going to start playing around a bit more in our own template file. Feels like quite a quick stream though. But yeah, that'll do for today. I hope it's been interesting. Thanks for people who've been lurking. And yeah, we'll see what we get for the next time. Cool, thanks. Bye.